Hello, everyone. Welcome back to Pre-Calc with Passmore. Today, we are going to talk about section 7.3, the second half of it, sum and difference identities. Last time we were talking about section 7.3, we developed cosine sum and difference identities, which is, you can see right over here. We developed this guy, and then today we're going to do sine and tangent. So our learning objectives are to use the cofunction identities to develop the sum and difference identities for sine and tangent. Yes, we're going back to cofunctions. And then the last learning objective of this section is to use those sum and differences to verify other identities. Basically, that's like the main point of once we have more identities, our whole purpose for having them is to prove other ones. So let's get into it, shall we? But today, I have something a little special for you guys. For those of you still tuning in, I have something that I just have to share. It's been traumatic. It's been rough. This is my third time recording this. I didn't like the other two that I had. I could have posted them for y'all, but I was like, no, I wasn't feeling it. I don't know, I get overly picky about how these come out and look. And then I have a story for y'all. So, story time. Before we get into the math, you guys get to hear some of my famous dramatic stories. So, we spend a lot of time at home, and essentially what's been happening is I've been under attack. Essentially, I've been literally under attack in my own home by the bane of my existence other than grading, and it's like literally just been the worst experience. In the last week I have seen like 8 spiders in my own house, and you guys, you don't even know, like, I am terrified of spiders. I lose my mind. I cannot hang with spiders, right? This is me. Every time I see a spider, I'm flipping out. I cannot handle it. I don't even care if it's a baby one. I scream like literally almost every single time. It's just a guttural reaction in my body to seeing those deathly, creepy, scary creatures. Yes, I know. It's irrational. They're probably not going to get me. Nothing's going on. But I don't know, man. I can't. I cannot hang with these spiders. So, to give you the deal, the short end of short end of the stick. Last weekend, went into my garage. I was casually just taking out the trash. I was being such a good roommate, taking out the trash, right? And I look to my left, and there's this teeny tiny little itty bitty baby spider, like so small, like I felt comfortable squishing it with my thumb, like that. And they've got to be pretty freaking small. Okay, so this teeny tiny spider, and so I squish it, and I'm like, cool, whatever. So I turn back, and I'm going to open the door, and I look to my right, and my hand is on the knob, and I look, and we have some things leaning up against the wall, and there's this huge black widow spider. And so I scream, and I turn around, and then I look, and there's another huge spider, and so I scream. I think I don't even remember if I threw out the trash. I have no idea. I just kind of blacked out. I ran inside. My roommate came running over. She's like, what's going on? What's going on? And I was like, there's spiders. And she's like, let me see, where? Because she's not afraid. This is the best type of situation to have. I'm afraid, she's not. So she coaxed me to go out in the garage, but I was like, no, I'm not going over there. So I'm pointing to them. I'm like, they're over there. That's where I saw them, blah, blah, blah. She's like, it's all right. I'll kill them. And I'm standing next to this. We've been doing a lot of home improvement things. Standing next to this thing that you put things that you paint on top of. It's like this little wooden stool type thing. And I'm sitting there, and I'm telling her about my traumatic story, and she's like, oh, you mean like the one right there? And I was like, what? And it was literally right next to my leg. So I was like, tripping. So we went to the store, and we got bug spray. And I couldn't even spray because I knew they were going to come out. So my mom came over and she sprayed for the bugs for me in the garage, because I'm pretty sure we have an infestation going on in there. Because then when my mom came over and she sprayed, she found 4 more spiders and killed those. And I was like, yeah, hell no. I am not about that life. Anyway, so that's not even the story. That's just me freaking out, thinking that my whole life I'm just like, I think it's because I killed that baby spider, and then like everyone's just like, assemble, she's the one, and they're just coming after me. I can't. So a few days later, this teeny tiny little itty baby spider, I like looked down and it was in my bed. So I squished it too because it was a comfortable, size to squish. And I was like, what the hell? So last night, I'm, you know, doing what we do during these quarantine times. I'm on TikTok. People, I'm on TikTok. It's late. I did not go to sleep. I got sucked in. It's like a casino. It's like 2 a.m. And I kid you not, I'm like snuggled up with my pillow and I see a freaking spider crawling on the pillow that I am snuggling. So I'm freaking out and I see it and I literally just throw my pillow up against the wall and I freak out and I get out of bed and I'm losing it. And so I was up for a while. I was freaking out about that. I was squishing everything. I had to I couldn't even scream because it was 2 o'clock in the morning. I'm not going to wake up my roommate from screaming from a baby spider, but it was in my bed. That's not even the worst part. So I'm riled up, right? I'm like not even comfortable sleeping in my bed at this point. I'm like, nope, this isn't gonna happen. We're not doing this at all. So I finally, I'm like, I'm just gonna go in the office. I'm just gonna hang out in there, blah blah blah, till I calm down, uh, do a couple things on the computer, whatever. And then it is no joke, 5 o'clock in the morning, and I'm so tired. I'm so tired, and so I'm like, I'm gonna go to bed. The spider's not there anymore. He wasn't there. I made sure he wasn't on that. I don't know where he went, but he's not on there. I'm so tired. So I walk into my room. It's still dark. And I was like, just turn on the light for one good measure. Just look around. And I kid you not, a completely different spider was on the wall to my right. Right there. Do you see that? Do you see this freaking guy? And yes, it's blurry. I took a video. I was freaking out about it. It was 5:15 in the morning, but in comparison to my hand, I have small hands. That's a pretty big freaking spider. So I'm tripping the hell out. And I just luckily right below him on the wall was shoes, so I was able to kill him. I was able to squash him, but I was just like, dude, I can't sleep. So I stayed up until like 7:30 this morning, and I didn't sleep. And I started taking everything out of my room and cleaning. And it wasn't even that messy, but just doing laundry and just I still have to vacuum every square inch because I can't have this happening to me. I just don't really know what's going on. So I was like, nope, I'm getting out of here. That's so bad. So I'm thinking, not today. I cannot. I just can't. I'm so terrified of them, and I had to tell you guys because it can be boring during this distance learning. But I swear to God, these spiders are coming for me, and I cannot have it. I wanted to burn the house down, but I don't own this house. It's just I don't know what's happening. I don't know where they're coming from. I don't know why they're attacking me, and I just I needed you guys to know because my roommate thinks I'm ridiculous because it's irrational. And my mom thinks it's funny to taunt me with spider pictures, and everyone just knows I'm dramatic, but I literally just talking about it, my blood pressure is high. I I haven't been that scared in a really long time. Anyway, let's do some math. That's my story. Last time we were in 7.3, we were talking about cosine, sum, and difference, and we did 3 different types of problems as we were working through them. So just to refresh our minds and our memories, we did finding exact values for non-standard angles. So we found cosine of 75 degrees, which we don't know unless we used a calculator, right? Or even 15, or we could find I don't know, something random, uh, another random degree measure. Using that. So that was pretty sick, right? Using the sum or the difference identities. We also used it to simplify an expression. So we went from a really large expanded thing and simplified it down to 1, and then simplified and found the exact value. Remember, what's cool about having identities is we can either expand or contract, which is really neat. Once we have proven something is equivalent, we're able to do that. And we also gave like some constraints and some restrictions, had to draw some pictures, find out some other values, and then use that information to plug into the sum and difference to find out other missing values and determine cosine of alpha plus beta or alpha minus beta. So that's what we did last time. So today we're going to move on and talk about sum and difference identities for sine and tangent. So way back when, it seems like a million years ago, it was definitely pre-corona times, we talked about cofunctions, right? Sine and cosine, those are cofunctions. Tangent and cotangent, cofunctions. Secant and cosecant, those are cofunctions, right? Remember, it's the complement. So sine of theta is cosine of the complement, 90 minus theta, and vice versa. Cosine of any angle theta is equal to sine of 90 degrees minus theta, its complement. We figured all these guys out. And today we're going to kind of circle back to a few of them because we're going to use this to identify cofunction identities. Not even anything really crazy. We're going to use them in radians instead of degrees, and use that to establish the sum and difference identities for sine and tangent. So specifically speaking, we are going to be talking about the sine and cosine cofunctions to get sine and tangent developed. And some of these I'm going to go over kind of quickly just because the proofs can be a little bit more challenging. And in addition, like versus not showing them at all, the purpose is to just kind of plant some seeds for you guys to have just additional insights on various ways which you can prove identities. So that's like the main purpose, but one of them in particular is really like I still have a hard time wracking my brain around it, and I've been thinking about it for like 3 days. So don't feel discouraged if that happens. I'm the kind of person where I'm gonna have to figure it out and get my life straightened away because it's driving me nuts. So we are going to use sine and cosine cofunctions right now and eventually develop identities for sine and tangent. So the one on the left is the first problem we're going to hit up, and it's actually a little bit easier than the second one. It's really not too bad. So before I can come up with the sum and difference identities, I have to verify that cosine of pi over 2 minus theta does in fact equal sine theta. So now instead of using 90 degrees, we're using pi over 2. I need to make sure that this is correct in order for me to be able to use it in the future. So since we developed the difference identity for cosine, notice I have a difference right here, pi over 2 minus another angle, theta. I can use that, and that's exactly what I'm going to do. So I have cosine of pi over 2 minus theta equals cosine of pi over 2 cosine pi plus sine pi over 2 sine pi, or sine theta. And that is just the cosine difference identity. Going from the left-hand side, and I'm eventually going to work to the right-hand side. So I'm using the left-hand side right here, expanding it out using the cosine difference identity. Now, what was cool, and you guys probably liked about section 7.3, what we had covered, is that you get to actually start evaluating things with values that we know. So the angle measure that we know here is pi over 2 or 90 degrees. So we're just going to plug in cosine of pi over 2. Remember, that's 90 degrees, and that coordinate is 0, 1. Cosine is 0. Sine is 1. Plugging those in, I'm just evaluating cosine of pi over 2. And anything times 0 is 0. And anything times 1 is 1. So we just end up with sine of theta when we simplify. And that's exactly what we wanted to do. So that really wasn't too bad at all. But we were able to do this nice and quickly because we did have this cosine difference identity already. This next one is the one that's been racking my brain. And I think I've developed like a really tedious and annoying like alternate reasoning proof, but I'm not even going to show you guys because it has two substitutions looking almost exactly the same. I didn't use different notation, and then resolving for and resubstituting back in. And it's just I'm just going to go with what the text had gone through and showed us for this next problem. But this one is super challenging. Even I struggle with it. So we want to verify basically the converse, the sine value. So sine of pi over 2 minus theta equals equals cosine of theta. I want to verify this. But I want you to think about, how would you do this? So far, we have a bunch of different identities, right? We've got our Pythagorean theorem identities. We have the cosine difference identity, but we don't have the tools to be able to do this in the exact same way yet that we did this problem. I don't have a sine difference identity yet. We haven't talked about that yet. We're actually trying to build it. So these are usually a lot more challenging when you're trying to build up from something that you already have and not taking something for granted. This is a very, very easy proof. Once you do have the difference identity for sine, it's literally like a 3-proof line like this, but we don't have that yet. So this is why this one is really, really tricky. So observe that we can't do this in the same way because I don't have a sine sum or difference equation yet. I don't have anything to substitute that in like we did over here on the left-hand side. So we're going to have to get a little creative. And when I say a little, I mean a lot. So we have sine of pi over 2 minus theta equals cosine of theta. But I don't have anything at all with sine and that difference. So I can't really work with that. So maybe working with cosine would be better. So what we're going to do, and this, like I said, this is a stretch, is we're going to use the cosine difference identity and then replace theta with a different number. And we're eventually going to get back to something that looks almost like this. So since I don't have anything to work with on the left side, and this is just a single thing, I am going to work with something that's not even in this equation right now. And kind of work to get to a place where I have something that looks like this and get an equivalency. So like I said, this one's a super big stretch. The one that I did is I started with the right-hand side. I had to work backwards after I had seen this and made like a substitution and then a second substitution and then worked through and then back substituted. If you're interested, I'll show it. I'm still not even entirely sure that that's correct, but for the sake of time, we're going to go with what the text did. So we're going to work with that cosine difference identity, and we're going to substitute in a different value for theta. So this is the cofunction identity for cosine, right? Cosine of pi over 2 minus theta equals sine. That's exactly this that we have on the left-hand side. Note, it's nothing that we have right here. That's close. It's just cosine. They're swapped. And now we're going to let theta equal pi over 2 minus t. So we're going to let theta be, theta, remember, is any angle. We're going to call it pi over 2 minus t, where t is any real number, any value around that unit circle. So I'm going to substitute that guy in. Let's see. So I'm saying theta is going to be pi over 2 minus t. So everywhere I see a theta, I'm going to plug in pi over 2 minus t. Simplifying this left-hand side, I have pi over 2 minus pi over 2 plus t. And this guy just remains pi over 2 minus t. So I end up getting pi over 2 minus pi over 2 plus t. Ends up canceling these two guys out. So I end up with just cosine of positive t equals sine of pi over 2 minus t. Now, this result, remember, t is any angle measure, theta is any angle measure. This is what we're using, and I got cosine of t, theta is any angle measure, cosine of theta, any angle measure. This is how we're verifying that this is the same. So I kind of did this weird roundabout. Well, it's not even my idea. The textbook did this weird roundabout, like manipulation of an identity we already have that ended up showing that this other identity is true, which is very different than how we have been practicing verifying or proving things. We've been working left-hand side to right-hand side to left-hand side. So like I said, this one's super, super interesting and strange, but let's just take it as is because I want to have these identities available for us to use, and I'm not going to ask you to prove them. So this ends up giving us these two cofunction identities in which we're going to use to create the sum and difference identities. So cosine of pi over 2 minus t equals sine of t, sine of pi over 2 minus t equals cosine t. That's for any angle measure t. So take a note, write this down in your notes because we are going to use it, but not abuse it. We're just going to be using it. Okie dokie. We are going to develop the sum and difference. Like specifically, we're going to do the difference identity for sine. We're going to develop that. So the sum and difference identities can be developed using the cofunctions, which is why I brought them up. I have to have them validated in order to use them. So since sine of t equals cosine of pi over 2 minus t, that's what we just verified. If we let t be alpha plus beta, remember t is any angle. If we just let it equal two different angles added together, or the difference, we can work from there and we'll end up getting that. We will end up getting a sum or difference identity. So this is our cofunction identity that we just showed. Sine of t equals cosine pi over 2 minus t. We are going to take this and substitute in alpha plus beta for t. So everywhere I had an alpha and everywhere I had a beta, everywhere there's a t, I'm going to let alpha plus beta equal t and substitute that right on in. Nothing crazy. So the left-hand side, sine of alpha plus beta equals cosine of pi over 2 minus alpha plus beta. Now, working on the right-hand side, I am going to regroup this. It's kind of like the associative property, because if I distribute this negative through to both pieces here, I have pi over 2, minus alpha minus beta. And if I think about it, I can regroup that and I will always get the same result. So whereas the parentheses were over here, we move the parentheses to the left, and that's typically associative property. But think about like if I had 1 minus 2 minus 3. And this was the original grouping that we started off with over here. So after distributing that negative, I have 1 minus 2 minus 3. No matter how we regroup it, if it's this way or that way, we still get negative 4. So that's why I'm able to regroup this argument. And then now I have a difference identity that I can use, right? So this, if this whole thing right here is alpha minus beta, I have cosine of alpha minus beta, that I can use the difference identity for cosine. So cosine alpha, cosine beta plus sine alpha, sine beta. Remember this guy, this whole thing right here is alpha. And this whole thing right here is alpha. And now I have to just distribute. And doing so leaves me with sine of alpha plus beta. This guy still drops right down. This is going to become sine alpha cosine beta, cosine alpha sine beta as my result. Because cosine of pi over 2 is 0 and sine of pi over 2 is 1. So I have a sum identity, and this is what we're going to be using. As similarly, if I plugged in, instead of alpha plus beta, if I plugged in alpha minus beta, I would get the difference identity in the same way. So I want to just bring them here to you. I don't want to go through another proof like that. I want to get to like the problems that you guys will be working on. So the sine family is going to be sine of alpha plus beta equals sine alpha cosine beta plus cosine sine alpha and beta. Notice that the functions alternate. So sine, cosine, cosine, sine, but the signs repeat. So whatever I have sine of alpha plus beta. I have, oops, addition. That's really bad. I have addition going on. And again, we can use this to expand or contract. Now, similarly, if I had sine of alpha minus beta, it's going to be sine alpha cosine beta minus cosine alpha sine beta. My functions are alternating and my signs are repeating. That is something completely different than what cosine did. Cosine had the functions alternate, but the signs change. So careful, sine has the same sign in the identity, unlike cosine. Also, in tangent, we have that the signs match in the numerator. So if I had tangent of alpha plus beta, I'm going to have tangent of alpha plus beta repeated on the numerator. However, it changes in the denominator to a different one. So if this is, pardon me, if this is addition, the denominator is a different sign. And it has 1 plus tangent alpha tangent beta. So we repeat this value on the numerator, 1 plus or minus multiples of tangent alpha tangent beta. And again, we can use this to expand or contract. Tangent has the same sign on the numerator and a different sign on the denominator. You need to notice that and take that down as a note for yourself. Take a second, write these down as we're going to use them. Tangent, I didn't talk about how that could be derived, but tangent can be derived using ratio identities, which looking at that, it's a little bit too crazy. So if you were curious, exercise 78 in the textbook will ask you to do that, but I'm not going to ask you to do that. I'm definitely taking it easy on you guys because I know that this can be really, really a struggle during this time. So I don't want to overwhelm you with tons and tons of work. Okay, so hopefully you have these down. And now we finally get to do examples of using them to either verify a new identity or do something, some other side of proof or something like that. So one type of thing that you might encounter, one of the usual suspects, would be to simplify expressions. Just like we could simplify when we used cosine, we can do the same thing with sine and tangent, because remember, they can be used to expand or contract. I can go from this simplified to this expanded side. I can go from this expanded side to the simplified, and vice versa, since it's an identity. So the problem that we have is we're going to rewrite this sine 2t cosine t plus cosine t 2t sine t as a single expression. Our goal is to write this as a single expression in terms of sine. So looking at this, I notice that we have a summation here. So I'm probably going to have to use summation, right? And I also notice that I have sine, cosine, cosine, sine. So they're alternating. And then I have 2tt, 2tt, alpha, beta, alpha, beta. So I know I'm going to have to use the sum identity for sine in order to condense this. So just as a refresher, here is our sum identity for sine. Sine of alpha cosine beta plus cosine alpha sine beta, that's equal to sine of alpha plus beta. We are starting on this left-hand side and simplifying it to the right. So all we really have to do is identify what alpha and beta are. Alpha is going to be 2t, and beta is going to be t, because we can clearly see that if this is alpha and beta, alpha, beta, alpha, beta, if I have this, there's my alpha. If I have this, there's my beta. Oh, look, there's alpha again. There's my beta. So 2t is alpha and t is beta. So substituting that in on the right-hand side, I have 2t plus t. And this actually isn't that bad at all. 2t plus one more t is 3t. So I end up with sine of 3t is my simplified expression. And I reached my goal. I have a single expression with sine of 3t. That's as simple as it can get. So I think you guys are going to like those problems. Example 4b is still simplifying using sum or difference, but we're going to use tangent this time because sine was super nice. And tangent isn't really that bad either. It's just, it looks a little bit more complex because their sum or difference identities are a little bit more complex at first glance, but I promise they're not bad. So we are going to use the sum or difference identity for tangent to find the exact value. Now, this requires a little bit of back work. I will tell you that it does require a little bit of back work that seems tricky at first, but once you get comfortable and get in some practice, you'll be okay. Now, 11 pi over 12, I don't know that value. I couldn't tell you what that is. So since I want an exact value, I know that 11 pi over 12 is either going to have to be a sum or difference, because it tells me to use a sum or difference identity of something that we know. We're never going to have something that we don't know. We're always got to figure out what's something that we do. So we have to think back to the unit circle. So, all right. I don't know why I didn't type this. Unit circle. Oh man, I can't. Okay. You get it though. I'm going to think back to the unit circle and see if I can find two values that I know that add up to be 11 pi over 12, or subtract to give us 11 pi over 12. Now remember, we have 0, pi over 2, pi over 4, pi over 3, pi over 6, all of those different types of angles we have. So can I figure out some of those to add up to give me 11 pi over 12? Yes, I can. 2 pi over 3 is a value in the unit circle that I know, and pi over 4 is a unit in this is a value in the unit circle that I know as well. And if I add those together, I end up getting 11 pi over 12 as the LCM. So this is what I'm saying when can be a little bit of back work here. This is probably the most challenging of these types of problems, since it wants us to find an exact value of something we don't already know. Okay, so I'm going to use this though. So here's my sum identity for tangent, right? I know that since this right here is a sum, I'm going to have to use the sum identity. So tangent of alpha plus beta equals tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta being multiplied. Now, 2 pi over 3 is going to be my alpha, right? Everywhere I have an alpha, I'm going to put a little me. And pi over 4 is going to be my beta, me. And that's the very next step, is we're just going to plug in what we know. So tangent of 2 pi over 3 plus pi over 4, plugging it right, alpha is equals to 2 pi over 3, beta is pi over 4, right into our identity is what we're going to be doing. And then whenever we have values we know, we get to evaluate them. So tangent of 2 pi over 3 is negative radical 3. Tangent of pi over 4 is equal to 1. So I just end up getting, if I'm working on the right-hand side, negative rad 3 plus 1 over 1 minus rad 3 times 1. And then I simplify this guy. And I end up with an exact value, right? Not too bad. Like I said, this is probably the hardest part right here, the initial setup when it's a value that we don't already know. This is the hardest part, determining a value that we don't know. This is hard. Oh my gosh. Typing or writing on a mouse is really tough. But we did it. It's not too bad. Okay, so since we have the other sum and difference identities for sine and tangent, we're able to add this to our mathematical tool belt to help verify other identities. Check it out. There's our tool belt. We've got our math Bible. We've got our calculator. I use these types of pens, maybe some money to bribe me with. I don't know, protractor, Band-Aid in case you get hurt. Not even sure what that is. Found it on the web, right? But we're going to be able to use these to verify other identities. So the last two examples, we're going to do exactly that. So verify that tangent of theta minus pi over 4 equals tangent of theta minus 1 over tangent of theta plus 1 is an identity. Notice that this is not something we have already established. We have Pythagorean identities, we have sum and difference identities for sine, cosine, tangent, we have our cofunction identities, we have reciprocal identities, ratios, symmetry identities, so many different identities, but we don't have this. This is not something that we've proven and put in our tool belt. So we're going to use what we have to verify this is an identity. And since we're talking about sine, cosine, and tangent, we're going to use one of those. So first step is we're going to use the difference formula because I have a difference right here. Tangent of theta minus pi over 4, that means I'm going to use the difference formula for tangent to get the desired result. So we're going to work left-hand side and end on the right. So here's my, this should have been a difference identity for tangent. We don't want the sum, we need the difference. I knew there was something I was missing. Difference identity, and this should be a minus, this should be a plus, and this should be a minus. I'm pretty sure I fix it in the next step. Oops. So just reestablishing what we have. There we go. There's our difference identity. And we're going to let alpha be theta. We've got theta, so that's my alpha. Alpha is theta. And similarly, beta is pi over 4. And plug that into the right-hand side. So plugging that in gives us tangent theta, tangent minus tangent pi over 4 is 1 plus tangent theta, tangent pi over 4. Now, what's great about these identities is once we have something definitive that we know, such as pi over 4, we get to evaluate it. So tangent, we're still working on the right-hand side. Tangent theta remains. Tangent of pi over 4 is 1. 1 plus tangent theta times 1 is just leaves us with tangent theta minus 1, 1 plus tangent theta. And then I just rearrange the denominator in order to get what I want. I noticed that the numerator is good, check, but the denominator, I had 1 plus tangent of theta. And I wanted tangent plus 1, associative property of addition, that's the same thing. So get it? Boom. Not too bad. Not too bad at all, not too shabby. So let's get to the last one, shall we, and get it over with. Okay, so this one is a little bit longer, but it's not that bad. This one I actually kind of have a little bit of fun with. So we're going to verify that sine of alpha plus beta times sine of alpha minus beta equals sine squared alpha minus sine squared beta is an identity. This one goes back to her Pythag. This one uses both the sum and the difference identity for sine because notice the left-hand side has a sum and it has a difference. So we're going to use both of them. So I always like to say what we're going to do beforehand. We're going to use both the sum and difference formulas to manipulate the left-hand side and work to get the right-hand side. So let's use what we know. We have our sum and our difference formula, right? Here's my sum. Here's my difference. And I know my sum, my sum is sine of alpha cosine beta plus cosine alpha sine of beta, and my difference is sine of alpha cosine beta minus cosine alpha sine beta. Remember that the functions go sine, cosine, cosine, sine, but the sign stays the same depending on if we're working with a sum or a difference. So all I did was just substitute. This is the left-hand side, and I got I used my identity. Next, we're gonna do something kind of crazy. We're gonna FOIL this guy out. Remember, that's one of the strategies is FOIL if you can and see what you work with. But before we get too crazy on the FOILs, what I want you guys to think about for a second before you actually FOIL it is I want you to think and determine what do you think this times this is going to give you. Think back to algebra. What if I had a plus b times a minus b? What would that give me if I FOILed that guy out? And what kind of situation do we have going on there? Okay, that's enough time. It's kind of like a difference of squares, except they're not squared, but it's like a difference, right? So I know if I FOILed this out, I have sine of alpha cosine beta times sine of alpha cosine beta. I got sine alpha squared, sine squared alpha cosine squared alpha. And then the middle terms are going to cancel because of these differing signs here. Because they have different signs, their middle terms are going to cancel. And the last things I'm going to have is cosine times negative cosine, so negative cosine squared alpha, and sine beta times sine beta, sine squared beta. Since it's not a difference of, well, kind of. It's the reverse difference of squares. This is the difference of squares gives us this identity here. So notice that this and that is the same, right? So this is the simplified version, that's the a squared minus b squared. This is the expanded version, that's a plus b, a minus b. Now, if I simplify this using my Pythagorean identities, I can get everything in terms of sine, right? Because the right-hand side has sine squared alpha minus sine squared beta. I had cosines in here. I needed to get rid of the cosines. And I know sine squared plus cosine squared is equal to 1. And if I solve that for cosine squared, I get 1 minus sine squared. So I'm plugging those in for whatever values I have. This one's beta, this one's beta, this one's alpha, this one's alpha. That's my Pythagorean identity, right? Then I'm going to distribute and work through and see what we get, right? Because right here, I don't really have anything else to work with. I need to get into a more simplified sine squared stuff. So I need to actually expand this out because this one and this one is a pest, and this minus is going to have to distribute that as well. So by the distribution property, sine squared times 1 is sine squared alpha. Sine squared alpha times negative sine squared beta is negative sine squared alpha sine squared beta. 1 times sine squared is sine squared beta, but we have that minus in the front here, which I failed to put an arrow with, my bad. So it's going to be minus sine squared beta. And sine squared alpha times sine squared beta minus minus is plus plus. We get sine squared alpha sine squared beta by distribution. Right, there's our first term, second term, third term, fourth term. And now, look at this. We're so close. Boom. We end up getting sine squared alpha minus sine squared beta because check this out. This guy is exactly the same as that guy. So simplifying gives me exactly what I want. And I did it. So I kind of like this one because it goes back to like expanding something out, distributing something, canceling something out, using our Pythagorean identities, all kinds of fun different algebra manipulations that end up start off getting really crazy and it looks a little overwhelming at first, but it ends up being this nice, beautiful, simplified thing. So here's your homework. The only homework for this week. I took it easy on you guys. Not necessarily because I felt that I needed to, but more so because I know this is challenging and I really don't want to overwhelm your guys' workload because you have 5 other classes than mine. So here's, I think 1, 2, 3, 4, 5, 6, 7 homework problems due Sunday, and they all align to either like the simplifying or proving identities, just like the ones that we did here. So thanks so much. I'll catch you later. I hope you enjoyed my story time. And I will catch you guys on the flippity flop. Peace. Bye.